Hello everybody, I hope you're all doing well. Root Beer here, looking at question number 14 on the 2018 Grade 10 Cayley contest. So let's have a look-see. What have we got for this question? Just a reminder, if you'd like to try this or any of the other questions before watching the videos, which I do try and recommend, you can get a copy of this contest by clicking the very first link in the description. Including the endpoints, how many points on the line segment joining -9, -2, and 6, 8 have coordinates that are both integers? These are sometimes called lattice points. We don't need to know that to do the question, but it's a useful thing if you want to learn more about them. Okay, now what we could do is come up with the line between these two. So -9, -2, we'll say that's down here, and then it was, I think 6, 8 is somewhere up here. So you probably could get a y equals mx plus b equation for the line connecting these 2 points. Now we don't really care about anything past 6.8 or past -9, -2. I said 6.8, I mean 6, 8. Okay, but how are we going to find these integer points? Well, if you did get the y equals mx plus b form, you could just say, well, I'll try each of the x values, -9, -8, -7, -6, all the way up to 6, and see, does the y also equal an integer? Okay, but you're going to have to check 16 different things. 6 minus -9 is 15, and we add 1 to make sure we get all 16. That'll be 16 things you have to sort of guess and check. Okay. Now the smarter thing might be to do, if you're again using a y equals mx plus b style form, would be instead to say, well, from -2 up to 8, those are the y values. My y values have to be an integer somewhere in that range, so that leaves me just 11 values to check. And so I put a y value in and solve for my x and ask, is the x an integer? And that's a fine way to do it too. Both will get you the answer, but they're going to be a little slow. So here's how I would do the question. Okay, so to go from -9 to 6 is to go over by 15. And to go from -2 to 8 is to go up by 10. Okay, so both of these have a factor of 5. So divide by 5, you're sort of going over 3 and up 2, over 3, up 2. So over 3, up 2, over 3, up 2, over 3, up 2, over 3, up 2, over 3, up 2. And this is exactly where the lattice points are going to lie. Because we start with -9, -2, we add an integer and add another integer to the -2, you'll still get integers. Now, why are you only going to get integers in these specific spots? Well, imagine for a second I had an integer between these first two. So I had some integer down here, this green dot. Well, that would mean that the slope of this line could be represented as integer and integer. So we'd go over m and up n, for example. So over m, up n. But that means that the slope would be rise over run, n over m. And we've already established the slope is 10 over 15, or 2 over 3. So n over m, if n and m are integers, which they would have to be if this green dot is an integer, a pair of integers, is a lattice point, then I'd just have another fraction representation of 2/3. But 2/3, the over 3 up 2, is already sort of in reduced terms, so I can't get a smaller one that sort of fits in and fills in the gaps at all. So that's how I can be confident that it's just over 3 up 2, over 3 up 2, and this is exactly where my lattice points will lie. So I've got 1, 2, because remember we want to count the endpoints, 3, 4, 5, 6 of them. So 6 is going to be our answer, and that's what we're going to look for here. So there we go, E6. And you'll notice both 16 and 11 are here, just in case you said something to the effect of, well, there's 16 possible integer values for x. I've misunderstood what they mean by both integers, so each one of those would count. Alright, but 6 is our answer, and so we will bubble an E, and let's get a fresh sheet of paper for question number 15. I will see you for that in the next video.